So our second part of properties of logarithms is going to be just going over more of the properties that we kind of covered a couple of them the last video. Not many. We really only went over the first two and the last two, but go ahead and copy these down real quick. Three of them have names and the other ones don't really have names, and then we'll talk about them. So the first one is log base b of b is equal to 1. That we talked about last class. That's a way to cancel and reduce your logarithms with your numbers. The power property states that if you have log base b of m to the nth power, that n can go out front of the logarithm, and then you get n log base b of m. So this is a power property. It could also be said that the number out front can be rewritten as the exponent if you were going backwards. So there are two types of ways to look at all of these properties. One where it goes from one side to the other, and then from that side back again. So product property and quotient property are very, very similar to one another. One is a product, meaning the multiplication. That turns into addition of those two logarithms. So we can actually expand the logarithm and write as addition, or condense the logarithm and write as multiplication, however you want to look at it. With the division, it's the expanding to subtraction and condensing to division. So it's kind of like your exponents rules, where you have the multiplication, you're adding, and you're dividing, you're subtracting. Very similar to those rules. So, and then we know that log base b of 1 is equal to 0, and then log base b of 0 and log base b of a negative number is undefined. That does not exist. So let's look at condensing, because this is what this means. Write the equation as a single logarithms means we are going to condense equation. So if I'm looking here, the first thing that I want to look for is if I have any numbers out front. If I have any numbers out front, I want to write them as exponents. And in this case, I don't, so I don't need to worry about that. But I'm going to write it as a single logarithm. I have subtraction here, so that's going to be my quotient property, where I write it as division. So that's going to be log base 4. Now notice that the bases are the same. You can't do this if the bases are different. The bases have to be the same for you to condense. So log base 4 of 32 divided by 2. I can actually simplify these numbers. Log base 4 of 16. And then now we have to think, okay, can I rewrite, or can I simplify this even further? Can I simplify this even further? That would be log base 4 of 16. I can simplify it by writing 16 as 4 to the second power. So that's log base 4 of 4 squared. And then we want to use our power property, because I have a power here. And I'll show you why we want to use that. We want to use that because it's going to make simplifying this a little bit easier. We put that power up front. We have 2 log base 4 of 4. And remember, if I have the base of what I'm taking the logarithm, they're the same. That equals 1. So this whole thing is equal to 2. So that would be a condensing problem. Now sometimes you condense and you don't simplify. And sometimes you expand and you don't simplify. So we're going to do a couple of more problems and examples. A couple where I condense and a few where I expand. So this one is going to be a condensing problem. And the first thing that I see is I see numbers out front. So I want those two numbers out front to be written as the exponents. That's going to be my first step. So this is going to become log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Now I see that I have an addition. Now that addition becomes that product property. So I'm going to write this as multiplication. Log base 2 of x to the 6th times y to the 5th. Now I can't combine them because they don't have the same bases, but that's it. That's a condensing problem. And we have successfully condensed as far as we can go. So the first part of condensing is to check for your power property. Power property. And in this case, we did the power and then the product, okay? So check that. Always the power property can go first. Now, another example would be log base 4 of 5x plus log base 4 of 3x. No numbers out front, so I don't have to do the power property. but it is addition, so I'm going to base 4 of 5x times 3x becomes 15x squared. And that is my final answer. These aren't supposed to be too terribly difficult. I wanted to just make sure that we went over an array of examples so that when you hit your work today, you didn't have any questions. So this is this is 2 log base 4 of x minus log base 4 of 9. I'm going to write that exponent, that 2 is an exponent. And then I'm going to have log base 4 6 minus log base 4 of 9. Now remember, if I have subtraction, that becomes division. So that's log base 4 of 36 divided by 9, which is log base 4 of 4. And log base 4 of 4 equals 1. So this whole thing simplified to 1. Now we're going to talk about expanding. Expand the logarithm. To expand the logarithm below, let's look at this one. Let's say I have log of 4x divided by y. So the 4x and the y, the first thing I would kind of start with is either the product property or the quotient property. In expanding, I would do the power property last. So either your product or your quotient. Now in this case I have both. I have product and I have quotient. You can do it in stages. I could write this as log base 4, base 10, because this is 10, there's no base. So log of 4x minus log of y. And then I can do the addition. So the addition would be to separate these. So I have log of 4 plus log of x minus log of y. Try this one really quickly on your own and see how you do. So let's say I have log base 9 of x to the 4th over 729. If I do this one, I'm going to expand it. I'm going to do the subtraction first, so this becomes log base 9. Oh, I'm sorry. I should have written this, pulled this up. So x to the 4th over 729. I would have log base 9 of x to the 4th minus log base 9 of 729. The only thing that you're going to want to check is these numbers, okay? So we are going to do that power property and move this power out front. So it becomes 4 log base 9 of x. And then we are going to rewrite 729, and we can actually try to write it with this base. So try to see if 9 to some power equals 729. That's what I try to check, because the base, if I have the base that's the same, then I can get the drop off those bases, and I could just have that number. And in this case, we can say that 9 to the power of 3 is 729. That power gets brought out front, and then log base 9 of 9 is 1. So this is 4 log base 9 of x minus 3. I have a couple more that I would like to do with you before we are finished with this video. Sorry if this video is a little longer than the others. But yeah, I just want to do, let's actually just look at one more. And that's log base 3 of 9x to the 5th. So I have the multiplication here, that becomes addition. So this is going to expand to log base 3 of 9 plus log base 3 of x to the 5th. We will take care of that 5 and bring it out front of my logarithm. But we're going to rewrite 9 as 3 squared. And that's going to be log base 3 of 3 squared. And then we're going to do the same thing with that too and bring it out front. So I'm kind of doing this at the same time. So I know that I'm going to have 2 times log base 3 of 3 is 1 plus 5 times log base 3 of x. Okay. That is all for properties of logarithms day 2. Now, you really want to know these properties very, very well and be able to work this very well. So I do believe there's quite a few problems in your practice today. But make sure you go and do that and complete the assignment.